So here is FABRIK method, which looks like this FABRIK demo. It basically some sort of robotic arm which is attached to a static first joint, and other joints they adjust bending and rotating and moving towards some kind of target, and target in our case is just a mouse position. Yeah, and the main idea, the problem itself is called inverse kinematics. Well, not maybe the problem itself is called, I don't know how it's called, but the fact is that we will solve the problem with inverse kinematics method. It means that we will adjust the bones positions and lengths from the backward. So we first adjust the nearest bone to the target, then the penultimate bone, and so on and so forth. Yeah, and I want to show how to implement this method. I will use raylib and C, and we will do it from bare minimum, from scratch. This is the final result. I already implemented it, and I'm recording this demo after the main session of coding. So enjoy the watching. Let's create a directory for project FABRIK demo. Now I want to get the raylib library. Yes. I will quickly create the basic structure of the project. Include directory, lib directory. What else do we need? That's it. Yeah, and since I'm working in Vim, I need how do they call it? Compile flags txt. It's just a small directive for Vim to understand where header files are located. Okay, and maybe I want Clang format. Yeah, Clang format is basically just formatting options for C language and C++. Okay, raylib is downloaded. Raylib here, unzip raylib. And since I'm on Linux, I can simply go to src directory and make the raylib. While it's building, I will copy some header files from the raylib source directory. We need raylib.h here. Also we need rgl here and rcamera here, and maybe raymas here. Yeah, raylib is built successfully. Now I put it in library directory. Raylib src lib raylib here. All right. Now let me remove raylib directory. I don't need it anymore. Okay, and this is our basic structure of the project. It's pretty simple. Now let me create main file and quickly write the raylib hello world example. Main void. I will create window. Let me include raylib first. Include raylib.h. Create, not create init. we need window, screen width, screen height, title, FABRIK demo. Now screen width, let's define it 1024, and screen height 1024. Okay, let's set FPS limit, set target FPS 60 for example, and main loop while window should not close, begin drawing and drawing, and let me create basic 2D camera. I prefer to work with camera. You have more control when you're working with camera other than with screen space coordinates. Static camera 2D, camera equal, let me check, it's okay. What do we have in here? Yeah, this stuff. Offset is basically half of the screen, because by default raylib camera is pointing to the top left corner, and we need kind of offset it on the half of the screen if you want the camera to be positioned at the center of the coordinate space. Half of the screen width, half of the screen height, screen height. Target is basically center of coordinate system. Rotation, we don't need the rotation here, and zoom, I don't know, let's pick 100 for now. Okay, camera, begin mod 2D camera and mod 2D, and let's maybe draw a circle, classic circle. Draw circle, vector center, vector to 0, include ray mass, vector to 0, radius, let's set it not 50, no, it's not a screen space, well, 1, color red, and also we need to clear background, clear the background, clear background, background color, static const color is equal, well, let's set it to some dark mode, 20, 20, 20, 255. Okay, and at the end I will close the window, nice. Now let's compile this stuff. FABRIK demo, GCC, output file is GCC output file will be here. FABRIK demo. We want to build this src. We want to build src.c. We want to include directory. We want to include raylib. Basically, first we want to set library directory eclipse. No, it is lib. and link with raylib. Now we want lp thread library, lmass library, and ldl. Nice. Fabric demo. This looks very cool. Let me create a simple, very simple make file with one single command, and you don't need even IDE with shit ton of config files. Make file. This is my IDE all. Output here. Here include, and let me set errors, not errors, warnings. I always forget how to set them. Warnings all, I believe. No. Oh yes, let me try. Make. Okay, Fabric demo. Nice. We have make file, we have basic structure. Now we can start the actual programming exercise. So we want to implement Fabric method for inverse kinematics, for simple inverse kinematic problem. So let's create a leg structure or arm structure. Leg, arm, 3 letters in leg, 3 letters in arm. Let me check. Arm is typing like so. Leg, no, arm is much simpler to type, but no. Anyway, struct type def struct arm. What is the minimum amount of information we need to handle the arm, to handle the robotic arm, for example? So first of all, number of bones, and maybe first of all the position, vector 2. Not the position, I will call it start. It's the first joint of the arm. Also number of bones, and now we describe bones. I don't want to create a separate structure for a bone. I don't like this. Maybe we will create it later, but now I want to keep it pretty simple. Number of bones. I need angles. Float bone angles. How many? So I want to know this the size of this array statically at compile time. So I need to set some maximum number of bones, max and bones, and also I need bone length, max and bones. Let's set it to for example 4 for now. Yeah, that's it. That is it. Now let me create the arm. Well, let's say we have let me think. Let's say that we have one static arm, and I will simply just initialize it. Let me factor out this stuff into load function, void load, like so. And here I will initialize the arm. Here we are initializing raylib, or well, OpenGL basic stuff. And here we initialize the arm. So okay, arm start. Let it set to something like I don't want to put zeros here because zero is it's bug prone. I should say. Let's set it like 1 and maybe -1 at least. Arm and bones, let it be 2, no, 3 for now. Arm, bone, angles, the first angle. So I will keep angles in radians first of all, and the second, I want them to be relative to each other. So basically the first angle, for instance, pi times 0.25. Let me open the drawing tool. So let's say I have some kind of robotic. Oh my god, how straight this is. Let's say I have some robotic arm somewhere here attached to the ground, and the first bone is defined by its angle with the x-axis. This is x-axis, positive x-axis, and this is our first angle, and this is our first length. So let's say, yeah, quarter of a pi. Okay. Arm, bone, angles. The next one will be pi times 25, 0.25. It basically means that it will be the same angle, but now with relative to this new x-axis. Maybe like so. Okay. These are two equal angles. Okay, and now I define bone length. This one will be 0.9 for instance, this one will be 1 for instance. Okay, now let's draw the arm. Void draw arm. Yes, I understand that I have global arm variable, but I want to pass it by the pointer, because later I want to keep this arm in some kind of array of arms and whatnot, or maybe in a structure which I call like spider with arms, I don't know, and that's why I want to draw. I want to have a possibility to draw an arm by passing the pointer to this arm, to an arm. Alright, draw arm. Yeah, but in order to draw the arm, I need some kind of method to obtain get arm joints. Yeah, because as you can see, I don't store them actually in the arm itself. I store only angles and lengths, and I need somehow to calculate and return the actual joints to draw them. And since this is SHTC, I need some kind of return argument. How do they call it? Return argument, maybe. Vector 2 joints, max and joints. And max and joints is simply define max and joints is simply this stuff, max and bones, but plus 1. Plus 1 because we have 2 bones but 3 joints. You can argue that the last one is not a joint, it's just the tip of the arm, but in my experience it is useful to treat it like a joint, the actual joint. it's simple to draw it, it's simple to iterate over these joints, and it's just simple. All right, max and joints, and I need to fill this array with joints. The first joint, the zeroth joint 0, will be just arm starting position. And now I want to iterate for int I over the rest of the joints. So I starting from the first joint, I iterate until max and joints plus I. And what is the next position of the next joint? Let me think. This one is known. In order to obtain the second one, I need to put it horizontally and rotate on this angle. Okay, let's do exactly this. I will put it horizontally first of all, so it will be length is equal not joints, arm bone length. Let me grab the length of the first bone, so zeroth bone, but I start iterating from 1 and I will just I minus 1. This is the length of the bone. Angle arm bone angles I minus 1. Okay, so vector 2 bone, the actual bone, let's put it horizontally first of all. So length on the x coordinate and on the y coordinate is just 0. Now let's rotate this bone. Bone is equal vector 2 rotate bone, and this the first angle. Yeah, okay. And for now I have the following situation. I have some kind of beginning of the coordinate system. Yes, and I have this vector length and 0 0, length and 0 0. I rotate this vector, and but now it's not the actual bone, because now I need to shift it to the actual position such that this bone will appear here. I don't want to keep it here. And let's simply offset it. Vector 2, add bone and the starting position. But I can't just use this starting position, because actually I need to use the position of the joint, of the 0th joint. Then I will use first joint. That's why I need to use not start here, but joints I minus 1. And that's it. And actually the bone, now my bone, this variable, is exactly this green line. This is my bone. Or more precisely, it's the second joint of this bone. And this is exactly what I need. Now let me say that joints I is equal to bone. That's it. And now I can return the number of joints. It's simply not max joints arm and bones minus or plus 1. And now I just return arm and bones plus 1. Let me factor this out. Int n joins is equal arm and bones plus 1 and joins and joins. Let's try to draw this arm. I will create a simple static array right inside the function to store these joins. Static vector 2 joins max and joins. Get arm joins joins. Okay, now I can simply draw them. Int n joins for int I is equal to 0, I is less than n joins plus I draw a joint. Circle V, center is joins I, radius, I don't know, let's say red. Okay, let's check it. What the fuck? Oh my god. Yeah. Draw. Wait, draw. No. Draw arm. What the fuck are you doing? Finally. But it's not a correct result. It's not a correct result because let me explain why. Because the actual angle, as I said, it's relative angle. But here I want to obtain the absolute position of the bone. So for example, when I computing the angle for the last bone, I don't want this one. I store them in a relative manner, but actually I want this angle. Simply because I want to rotate the horizontal bone such that it will appear here. The same strategy as with the first bone. So I need to aggregate this absolute angle from iteration to iteration. Float angle total, let's say 0. Angle total plus equal this one, and here angle total. Yes. Oh no. Yeah. It is just it's just upside down because yeah, because if you have a circle, imagine a circle. Well, you may not imagine it because I will draw it. Here is a circle and the positive angles go clockwise. These are positive angles, so this angle is 0.25, but on my picture I put them in the negative direction. Yeah, so I just Now let me draw the bones themselves. Draw arm, draw circle. I am iterating over all joints, but how can I draw the arm? How can I draw this arm? I can draw it only when I skip, only when I processed the zeroth joint, because when I processing zeroth joint, I can draw only the joint. I cannot draw the arm. I don't have access to the second joint yet. So if I is greater than 0, it means I already here or here. So I'm drawing the second joint or the third joint. I can draw line vector. Start position will be the previous joint, and I can do this because I minus 1, it could not be less than 0, because I do it only when I is greater than 0. And position joints I and color ray white. Ray white, specifically ray white. But maybe I should increase the line width. Set where I need to include red gel. Set what the yes, set line width 2. No, 3. Yes. And I kinda don't like this. Maybe I should put it here. Yes. This is exactly what I wanted. Okay, and now the most difficult part. Now we need to apply the inverse kinematics method to this kind of arm. For now this arm is just a picture. I cannot move it, I cannot rotate it, I can do nothing with this arm. Now I want to implement the inverse kinematics FABRIK method to rotate and to change the position of the joints and so on. Draw arm. Well, let me factor out all this stuff into a draw function. Draw void draw void boom, and also update void update void. Okay, and here update. Let me think. Let me run it first. Okay, all is good. Update. Let's say the arm also has vector to target. Vector to target. I'll explain in a minute what does this mean. Update arm, not arm, update. Let's say I have I should repeat this algorithm before implementing this. Let me think. Void update FABRIK. Let's say FABRIK step. I can call the fabric step on some kind of on the arm. Okay, and here I'll implement FABRIK method single step, and somewhere here I will iterate over some number of iterations to perform n steps, where n is usually I don't know, 5, for example. FABRIK step. First we compute the backward path, and let me explain how this works. Can I use this one? Yes, maybe I can. Let me erase all this trash. I don't need it anymore. No. Fuck you. Fuck you. I don't need this anymore. Okay, it's enough. It's enough. It's enough. Let's say I have some kind of target. I don't know. Here. Yes, here. How can we even rotate this arm towards this target? Let's start from the very end. Backward. We will go backward. Let's say I just simply put this joint here. Okay. But also I want to preserve the actual length of the bones. So I will take this bone and rotate it here and preserve the length. So basically I rotate it like so, but I preserve the length, and this bone appears here. Okay. Now I repeat the procedure, but with this joint. So, with this joint and with this bone. So I rotate it like so, and this joint appears here, and I also preserve the length of the bone. And this is my arm. But as you can see, we have some kind of a gap here, and we want to get rid of this gap. But we will in the forward path. For now, let's implement the backward path. Backward. Okay, the first step. I want to iterate over all joints and just adjust their positions. And luckily, we already have the joints, the function which will provide joints for us. Joints. And now I iterate int I is less than n joints plus I. And where should I put my first joint? Well, not the first. No, it's not correct. I iterate backwards. So int I is equal to n joints minus 1. This is the last joint. Until I is greater or equal 0. And minus I. Okay. First, let's compute this direction. This one, and this joint position, This joint position we can already we can write it even before the actual loop, because joints, the last joint position, and joints minus 1, and this is the last joint, is equal to arm target. Yes, we just put it in the target. Now let's compute the direction. vector to direction. What is the direction? We take this joint, we take the next joint, actually not this one, actually this one, and we just compute the direction. That's why I don't want to start with from the last joint. Maybe I want to start from the before the last penultimate joint, penultimate. I don't know the English language. Okay, direction will be just a difference between this penultimate joint, joints I vector 2 subtract this one and the previous one, joints joints, yes, I minus 1. Well, the previous one means the last one, so I plus 1 actually. Yes, this is my direction. And now I want to, what do I want to? I want to set the next joint position, this one, to be equal to the direction times scaled by the length of the last bone. Yes, float length is equal to arm bone length, and let's say that I have 3 joints. On the first iteration it will be I equals 1, so on the first iteration I equals 1, and I have 2 bones, and 1 means the second bone. Yes, I just put I in here. This is length, and the next joint position, joints I plus 1. Let's say I is equal to 1, joints 2, no. Oh, yeah, what, like so, joints I is equal to vector 2 scale, direction, and length. And I want to add vector 2 add the previous one. Well, and since we are going backwards, the next one, I plus 1. Oh. Yes. Let's check it, but frankly, I don't. I'm not sure that this is correct one. We will debug it later. Well, not later, but now. Actually now, right now. Let me just update the arm. Fabric step arm. No. I cannot. I also need to update the actual arm, because now I have only joints in my static array. The actual arm doesn't even know about these joints. So I need update arm for, let's iterate over all joints less than n plus plus I. And I want to compute relative angles. Relative angles. Yes, so let's say on the first iteration I will be located at this joint. This is the first iteration. But I kinda need the next one because I want to obtain this angle. Yeah. So let me start iterating from the first one, and it means that I have the next joint, this one. Let me call it B, and also I have the first one. Let me call it A. And now I want to compute an angle between an angle which is created by this bone and x-axis. But remember, what I want relative angles, so first I will track the absolute one, float angle total equal to 0. Angle between this stuff and this stuff. I need to get the difference. Well, actually I need to obtain this vector, and get an angle with the x-axis. Vector 2, subtract the difference. B minus A. Vector 2 angle. It's very useful that raylib has all these routines to compute angles and cross products, dot products, and whatnot. Vector 2 angle between this one and the x-axis. Let me factor this out. X-axis. Did I use x-axis? Did I use? No, I did not. No, I don't need this. 1 and 0. Yes, but this is just an absolute angle. But I need the relative one. Let me this stuff will contribute to the, no, it won't. This is absolute angle. Let me subtract angle total. On the first iteration it will be 0, and this is actually the relative angle, but angle total after that will be increased on this angle. Yes, and this angle, this relative angle, I want to write it into the arm bone angles. I minus 1 is equal to angle, because the first iteration will be I equals 1, and I want to write the value for the zeros bone. So I minus 1 is 0. Bone angle for 0 bone is angle. All good. Let me float angle like so, angle minus equal angle total plus angle. What a stupid shit. It's It's okay. It's funny math. Math. Funny math. Okay, we updated fabric step. Okay, let's try. Yeah, and also I want to specify the arm target position. Let's say vector2 target is equal to mouse position, get mouse position, but this mouse position in the screen space. I want to transform the screen space to the camera space. Get screen to world. Get mouse position, camera, like so. Arm target is equal to target. Yeah, and as you can see, something is happening, but obviously it's not enough to use only the backward path. We also need to use the forward one. But it's already something. And honestly, I don't even know is this correct one backward path or not. Let's implement forward path. Forward. And actually backward and forward they are pretty similar. Let me redraw quickly the picture. I have an arm. I rotate it to this target. This is our backward path. And now we perform the same stuff but in reverse order. Well, in forward order. So let's say that this is my target. This is my target. I offset, I shift this this joint to this target and build the bone towards this joint, like so, preserving the length. This is my first bone. Now I say that, okay, this is my target now. I rotate this bone, I preserve the length, and I reduce this gap. Maybe it's not obvious from my picture, but iterative process will reduce this gap eventually. Okay, so the first step. No, first. The very first joint of our arm will be placed in the arm start position again, like we started with this. Arm start. Now we want to adjust all other joints. Int I. Let's start with the second joint. With this one. So it will be 1 I is less than n joints plus I. Let me grab the length, arm bone length. This will be the first bone, the zeroth bone, so I minus 1. Direction. I want to take the second joint, the first indexed joint, and obtain this direction. So from the zeros joint to the first joint. Vector 2 subtract to the first joint. So this will be joints I, joints I minus 1. This is the direction. And the actual joints I, is equal to. So I have the direction, and now I want to offset this direction vector to this position, because this direction vector, it's just some vector from the beginning of the coordinate space, and I want to offset it here. Vector 2 at joints I minus 1, vector 2 scale direction length. I don't know. Maybe it's fucking bullshit. I don't know. Update arm angles. Yeah. Let me try. Well, not exactly. Forward. Fabrics. Yes, also. Let's perform this fabric step int I is equal to 0, I less than 5 plus I. Well, fuck it. Okay, wrong directions. But it's something. For some reason the first bone is not even updating. It means that the very first angle is not updating, the very first angle. For some reason. I iterate over joints. Yes. Angles. No, it should be updated. Bone angles is equal to angle I minus 1. Let me debug print it. I minus 1 angle 0 1 2. It looks correct. No, it's not. The 0 angle is always the same. It's not updating. Why it's not updating? Joints, it's not updating because B and A on the first iteration are always the same. Why so? A is the zeroth joint, B is the first joint. Let me print A and B joints. Let me print A and B joints. A X, A Y, and B. Sometimes they're the same for some reason. It's not correct. It is not correct. It's not correct. Okay, okay. Let me check the backward pass. No, it's not correct. No, but maybe it is. Maybe it's correct. Maybe it's correct. But maybe no. Let me think. Joints. The last joint is target. Yes. I iterate over all joints starting from the penultimate joint. It's n joints minus 1, it's the last one, minus 2, it's penultimate joint. Until, yes, greater or equal 0, minus minus I. I get the bone length. So, on the first iteration, 3 joints minus 2, I equal 1. I have 2 bones. 1 is the last bone index. So I get the length of the last bone. After that, I get the direction. Joints I. It means I is penultimate joint. I take its position and subtract from it the previous joint. So the next joint, the last joint. So my direction from the last joint to the penultimate joint. From the last joint to the penultimate joint. Okay. Yeah. It's a direction. It's a direction. Vector 2 normalize. Yeah, okay. Direction, scale by length. Okay. Forward. Vector 2 normalize. Okay, leap of faith. Almost, but something strange with why is it inversed? I don't quite understand. Let me put 16, for example, here. Yeah, for some reason it's inversed. Get screen to world, get mouse position, camera, target. I don't understand. Maybe, yeah, something wrong with angles, Let me think. So I start from the first joint. And iterate over all joints. I take the first joint, I take the 0th joint. I say subtract first joint. Yeah, so I'm going from A to B. Maybe I'm sorry. Yeah. Just wrong order of the x-axis and the actual direction that I want to rotate. X-axis goes first. Okay. And this is it. This is it. Yeah, it works perfectly. Perfectly. But you want, I mean, you know what? We also can compute the error. Because this process, it's not actually deterministic, it's kinda iterative, as you can see, and we can end up with in the situation where we don't have the perfect position of our system. Maybe we want to estimate this error. It's pretty simple. Float error is equal to, let's just take arm, not arm, joints. Let's just take the last joint, and joints minus 1, and just compute the difference with not distance with the target. So no matter how many iterations we will perform, let's say that our final position is like so. So we always end up in the static joint, because the last pass is the forward pass, as you can see. First backward pass, then forward pass, and forward pass fixes the zeroth joint of our arm. Yeah. And now, yeah, and let's say I have an arm, but my target was here, for example. Yeah, and I just take the last joint and target and compute this distance. That's it. And it will converge very quickly. After 5 iterations, we will have, I don't know, what is the, we have zoom 100. We will have maybe 0.05 or like so. I don't know. Let's return it and check. Error. Yes. Float error. Printf error. Wrong window. Yeah, it's basically I want to print error at the end of the iterations. Float error like so. Even if I rotate very quickly, I have really small errors. It converges very fast. So let's say while fabric step arm is greater or equal to is greater than 0. 0.01, I just continue with the I don't like it. Static, not static. Max and bone. Let's define max and fabric steps, like I don't know, 20. Define max fabric fabric error margin 0.01 for int I is equal to 0, I less than max n fabric steps plus 1 float error is equal to fabric step arm if error is less than or equal, no, let's say the less than error margin fabric error margin I simply break. That's it. Now let's check the number of iterations we usually do. Printf and we usually do the maximum number of iterations when the cursor is out of bounds of reaching. You get it. And usually we do 0, 3. Let's maybe handle this case separately. Just not to compute so many iterations, because we know if we out of the circle of the arm, we can just make the arm straight towards the point, towards the target. It's kind of corner case, so we need to handle it separately. I leave it backward. Let's maybe float length total is equal to 0 for int I is equal to 0, I less than what, arm and bones plus I, arm bone length I, length total plus equal if the distance from the arm initial position, arm start, arm first, I mean zeroth joint position, if the distance to the target is greater or equal than length total, I simply compute the direction vector 2 vector 2 direction is equal to vector 2 subtract target arm start. This is direction vector 2 what do I need? So I need to obtain angles. So if I have this case, arm, first joint, second joint, another joint, they are straight, these bonds are straight and pointing towards some target. I just need to compute the first angle, and all other angles are just 0, because they are relative, as you remember. I just need to compute the first angle. Arm angles, the zeroth angle, vector 2 angle between the x-axis and direction. And all other for int I is equal to 0 to 1, I less than arm n bones plus I. Well, actually I can do arm bone angles is equal to memset what pointer fucking see arm bone angles integer 0, how many of them, size of arm bone angles, like so, and just simply set the first one as the angle between x-axis and the direction. Technically I don't need to normalize it here, but anyway, I call it direction. So direction usually normalized, and CPUs are fast, so why not? No, this doesn't work. Yeah, of course, return 0. Not 0, but distance to the target. Dist to target, float dist to target is equal to this, return dist to target. Well, should I put, yeah, it's better. Return this to target, this is my error, and here return just error. Okay. No. Why? Length total. Let's debug. Print f. Length total 1.9. This is correct. Dist to target. Dist to target. Length total is dist to target. Yes. Length total is less than dist to target, obviously. Length total is less. Yeah. I need to return 0. Because yes, we have some discrepancy. Is this a word, discrepancy? We have some divergence between the target and the last joint, but we cannot do anything with it, so we don't need to iterate further to reduce this error. We can't reduce it because the target is very far from the last joint, so we need to return just 0. Yeah, and as you can see, we have 0 iterations. 0 iterations. Yeah, yeah, it works perfectly. It works perfectly. Let me quickly draw maybe frames counter. Draw FPS like position 1010. And now let's set it's funny that I have 3 bones, but I only defined 2 of them. Let's define another one like so, for instance. Yeah, and this is, it's just perfectly working, as you can see. It works perfectly. Let's one more. Yeah, yeah, it's very cool. Okay, so let me create the repository, but I will do it off screen already. So that's it. I suppose that's it. It was FABRIK method for inverse kinematic problems.